Hello everyone, welcome back to my channel. So in this video we are going to discuss the last 3 questions of the paper 970932, and here is the question number 8a. Solve the equation 1 plus 2 iota w plus iota w star, that is conjugate of w, is equal to 2 plus 3 plus 5 iota, and give your answer in the form of x plus iota y, where x and y are real numbers. So let's say that w is given in the form of x plus iota y, and w star is going to be in that case x minus iota y, because this is just a reflection of the point on the x-axis, so it would be x minus iota y. So now we'll put it in this and we'll solve and compare the real part and imaginary part of the right hand side to get the value of x and y. So it is the left hand side become 1 plus 2 iota into x plus iota y plus iota times x minus iota y, and this is equal to 3 plus 5 iota given. Now it become, if we'll simplify, we will get x plus iota y plus 2x iota minus 2y and plus x iota plus y, because iota square, because we know that iota square is minus 1. So I have used a simple algebra to simplify the brackets and use this property iota square is minus 1, and I got this. And we'll simplify it to take the like terms together. It would be x minus y, these are the real values, and for the imaginary we know that it is 2x plus x 3x, so it become 3x plus y times, because this is y here, is iota is equal to 3 plus 5 iota. Now we'll compare the real terms with the real terms and imaginary terms with the imaginary terms, and we will get two linear equation. So that is x minus y is equal to 3, and another is 3x plus y is equal to 5. So we'll add these two, we'll solve it by adding it. We'll solve it by adding. So 4x is equal to 8, so this gives x is equal to 2, and when we got x is equal to 2, we'll put it here and we'll get y is equal to 2 minus 3, that is minus 1, and hence the w, the complex number w, is equal to 2 minus iota. And here if we compare, it is like x is equal to 2 and y is equal to minus 1, which we have already written. I hope it is clear. So let's do the next part of it. Here is B, first part. On a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying these inequalities. And these are, we can see this is a circle, we can say disk because it is less than or equal to 1. Circle with center, it can be written as z minus 2 plus 2 iota, so that it will be completely visible that the center is going to be 2 comma 2, and argument of z minus 4 iota is greater than or equal to minus pi by 4. So we know that it is a half line through 4 iota, this is the half line with the angle minus pi by 4. So minus pi by 4, we know that it is going to be in from the x-axis, the initial line, so it is minus pi by 4, so it would be like this, it is minus pi by 4. So greater than this, so this part will shade. So let's draw it. So here is the real axis and this is imaginary axis. So we'll mark the points, required points. First thing is, like, we require to mark the center. Center is 2 2, so 2 here, 1 unit means 1 box means 1 unit, so this is a center, this is 2 2, and the radius is 1, so we'll draw a circle. So it is a circle with center 2 2. Now this is the half line through 4 iota, through 4 iota, so it is 2, so this will be 4 iota. I'll draw the line from here. This is the initial line, and the angle will be minus pi by 4. So pi by 4 means it is going to be 45 degree. 45 degree means if it is 1, then 1, 2, then it is 2. So I'll draw the line, line which makes minus pi by 4 angle. So this is a line which makes minus pi by 4, because we measure the angle from the initial line, so it is minus pi by 4. So this represents the half line through this 4 iota, and this is the line. And now if it is greater than minus pi by 4, so you will shade this region, and if it is less than or equal to 1, so we'll shade the inner part of the circle. So altogether we will get the intersection point, which is the required region to shade, is going to be this. This region is going to be the required region. I'll shade it properly. Then this is the region we require in this case. I hope it is okay. So let's do the next part of it. So here is the second part. Find the least value of imaginary z for points in the region, in this region. Give your answer in the exact form. We know that least will be, we will get it at this point. At this point it is going to be the least. Mark it O, A, and this is C, let's say. So in OAC we know that OA is going to be 2 and AC is also given as 2. So OC will be by Pythagoras theorem, it is going to be 4 plus 4, and that is 8, and 8 is 2 root 2. So this total distance is, I'll draw it here, and we need to know what we'll find. I'll draw the same thing here and we'll understand. The distance is 2 root 2, and if you'll subtract, because we know we require to find this distance from here to here, so we are going to subtract this, and this is the part of circle, you know this is radius, so it is 1 left, and in order to find this distance we'll find this distance as well, because it will also make 90 degree. So now what we need to find, what is this distance. Before that we know it is going to be 45 degree. This is 45 degree. We need to know what is this distance, and now we have this distance. Pythagoras theorem will subtract 1, so this distance become 2 root 2 minus 1, and this is 45 degree. So we'll use the sine 45 degree, and it would be opposite is the required value. I will take it as Im of z, imaginary value of z. So imaginary value of z over the hypotenuse, and hypotenuse is 2 root 2 minus 1, and hence imaginary of z is equal to sine 45 into this, and sine 45 is 1 over root 2 into this 2 root 2 minus 1, and we'll do the rationalizing the denominator. Will multiply by 2 and 2 in numerator, and in numerator we'll get 2 root 2 minus 1 multiplied by root 2, and denominator become 2, which can be simplified as, and we'll get 4 minus root 2 whole upon 2, and that can be written as 2 minus root 2 over 2, because we know that root 2 into root 2 is 2. I hope it is clear. So let's do the next part. Here's the question number 9. The diagram shows the curve y is equal to cos x and y is equal to k over 1 plus x, where k is a constant and x is between 0 and pi by 2. The curve touches at the point where x is equal to p. So we know that when two curves touches each other, then there will be two informations we know. One is at that point both the y values will be same, and if you draw a tangent, that tangent will be common tangent, and common tangent means common gradient. These two things we will use to prove that or show that P satisfies this equation. So at P cos P is equal to k over 1 plus P, because both the curves are same, coinciding at that time at that place where x is equal to P. So we can write x is equal to small p. And now what is dy over dx? For the first function, it is going to be minus sine x. Cos x differentiation is minus sine x, and dy over dx for second curve will be, it is going to be 1 over 1 plus x. 1 over 1 plus x can be written as, I'll write it here, written as 1 plus x to the power minus 1, and hence the differentiation will be minus k times 1 plus x raised to the power minus 2, which is minus k over 1 plus x whole square. Now we'll say at x is equal to p, these gradients should be same. If these gradients are going to be same, it means sine x sine p is equal to minus k over 1 plus p whole square. So I think now we can see, let me mark it as equation number 1, it can be question number 2, and dividing 2 by 1, we will get sine p over cos p is equal to minus, this minus will be cancelled because this was minus here, so these two will also be cancelled, and it become k over 1 plus p whole square, and cos p is k over 1 plus p only. And then we can see these two will be cancelled, this one power will be gone, and it is going to be 1 over 1 plus p, and hence we'll get tan p is equal to 1 over 1 plus p. And that's done. I hope it is clear. Let's do the next part of it. Here's the B part. Use the iterative. So in this B part, we need to use the iterative formula Pn plus 1 is equal to tan inverse of 1 over 1 plus Pn to determine the value of P correct to 3 decimal places and give the result of each iteration to 5 decimal places. So we know first of all that what would be the initial value. Initial value means P1. We'll take P1, and we know this that was intersecting, the curve were intersecting between 0 and pi by 2. So we can take 0, x was actually from between 0 and pi by 2. So we'll take P1, let's take it as 0.5. We can take 0.5, any value we can start in between, but if they are if it is given that it is going to converge, so P1 we can take it as 0.5. And now the hint, the trick to use this to solve this type of question, you first of all write 0.5 in your calculator and press the equal to button, so that answers store the value 0.5, and then P2 value you will get the next iteration as tan inverse of 1 over 1 plus P1. Here you are writing P1, but in the calculator while doing that you will be using the tan inverse 1 over 1 plus answer key, not the this value P1. In that case you don't have to do it again and again, and you will directly get this value as 0.5880 and so on till 5 decimal places. I have given the result. And then P3 will be, P3 you will get just by pressing the equal to button, means like you are going to write tan inverse 1 over 1 plus P2, so it would be 0.56197 and so on, so I'll write like that. And P4 is going to be 0.56946 and so on. And then again you press the equal to button and you'll get P5 as 0.56796 and so on. And then P6 will be, again you press the button and you'll get it as 0.56792. We can see it is same till 3 decimal places, but still we will not write it because the fourth decimal place is different. So let's take it as P7 just by making pressing the equal to button, and we'll get it as again 0.56774 and so on. And the one more iteration we'll check, and that is also coming 0.56779 and so on. Now we can see it's like it is correct till 4 decimal places. So the answer will write as P is equal to 0.56. It is 7, so we'll take it as 8 because the next value is 7. So it is going to be 0.568. I hope it is clear. So the thing to remember is you need to write this value on your calculator and try to store the answer value as 0.5, and the next will be like again you'll get the answer as 0.58800 and so on, the complete value. So you'll get the answer, the accurate answers. So let's do the next part. So here's the C part. Hence find the value of k correct to 2 decimal places. So we know that at p like x at x is equal to p, at x is equal to p, we know that cos p is equal to 1 k over 1 plus p. Now we have the value of p, so we'll transfer k 1 plus p other side. It is 1 plus p is equal to into cos of p, and let's use the value of p we got in the previous part, that is 0.568, and then we'll use the calculator. It is coming into 1 plus 0.568. Now we'll use the approximate value into cos of 0.568, and it is coming 1.3217 and so on, and hence till 2 decimal places k is 1.32 because they have asked till 2 decimal places. So I hope it is clear. So let's do the, here's the question number 10. With respect to the origin O, the point A and B have position vectors given by OA as 6i cap plus 2j cap and OB as 2i 2j 3k. The midpoint of OA is M. The point N lying on AB between A and B such that AN is equal to 2 times of NB. Find a vector equation of the line through M and N. So for the reference we'll draw the situation. So let's say this point is A, this point is B, and this point is O. So we can say this is OB vector which is given, this is OA vector, it is given, and in between this, so there is a M vector, and if we'll join AB we'll get N somewhere, so that AN is 2 times of NB, so N will be somewhere here. Now we can see that M is the midpoint of OA, so OM vector, position vector of M, that is OM vector will be half of OA vector, and that is half of 6i cap plus 2j cap, and that is 3i cap plus j cap. So let's make it as equation number 1. Now we have OM. For the ON, for the ON, what we'll do, we will find what is the AN first, and AN vector we can take it as 2 times of NB vector, and we know that if it is 1 and it is 2, then this vector, this portion will be 2/3 of the whole. So we will directly write ON vector as OA vector, OA vector plus AN vector, because we need to go till N. ON is OA plus AN vector, and OA vector we already know, so let's write OA vector as it is for time being, and then AN is 2/3 of AB vector. So first of all I'll write AB vector here. AB vector is OB vector minus OA vector, and that is, we'll get it from here. OB minus OA, 2i minus 6i, that is minus 4i cap, 2j minus 2j, that is 0, 3k minus 0, that is 3k. So it is AB vector. So we'll use it here, and that is ON vector, we got it as 6i cap plus 2j cap plus 2/3 of minus 4i cap plus 3k cap, which we can simplify, and we'll get, this is 6 and this is going to be minus 8. So 6 3 is 18, minus 8 is 10, so 10 over 3 I cap, and this is j cap alone, so it is 2 j cap, and it is 3 into 2 by 3, that is 2 only, so plus 2 k cap, and this is a ON vector. Let's mark it as equation number 2. Now we need to find a vector equation from the line through M and N. So parallel vector, direction vector in this line, in the equation of, like in the direction of this line, the direction vector we can take it as Mn. So we'll take Mn vector first of all, and we know that Mn vector is going to be On vector minus Om vector. This is just a formula. On is 10 over 3 I cap plus 2 j cap plus 2 k cap minus Om vector, that is 3 I cap minus j cap. So which can be simplified as 10 by 3 minus 3, 3 3 are 9, so 10 minus 9 is 1, so it is 1 over 3 I cap, and it is 2j, and this is j, so it is j cap and plus 2 k cap. So we got the direction vector as well. So we have, now I can write it as the first point. We know that equation of line in the vector form, vector equation is like r is equal to vector a plus t times vector b. So here a we can take it as Om vector, position vector of m. We could have taken On also, but On is little bit bigger, so I'll take this only. In both the cases we'll get the same answer, there is no difference in that, but we can take any value as the point on the line, and that is m. So in this case 3 I cap plus j cap, and b vector is the direction vector, that is Mn vector, which is 1/3 of I cap plus j cap plus 2 k cap. Hence the equation, vector equation of line is 3i, r vector r is equal to 3i cap plus j cap plus lambda times 1 over 3 I times 1 over 3 I cap plus j cap plus 2 k cap. If this is O, this somewhere it is B here, and then P will be here, and it is M, and of course will be here somewhere. So it says that this P is the intersection point of the line through OB and Mn, and we need to find the position vector of P. But we know that from here only that OP vector is going to be some multiple of n times multiple of, means n times OB vector, because they are in the same direction. So it is n times OB vector, and we know what is OB vector. So it is n times 2 I cap 2 j cap plus 3 k cap. Let's say it is equation number 1. This is the one way to say that it is OP. This is the one we can say the way to find the OP, that is position vector of P. But another way is, we know the equation of line through M and N, and the general equation we have, the vector equation of this line through Mn we have. So P is any general point on the line through Mn, so it can be written as 3 plus lambda over 3 I cap plus second value 1 plus lambda times j cap, and plus third value is 2 lambda k cap. We get it from the equation of the line through Mn, and then this is the equation, another equation, or we can say we have the position vector of same point in two ways. So it means these two variables, these two unknowns should satisfy the equation in all the cases. So it means if they are same, so we'll compare, we'll get 2n is equal to 3 plus lambda over 3. Next, if we'll compare the second j coefficient, that is 2n is equal to 1 plus lambda, and third one is 3n is equal to 2 lambda. So we'll solve from any of these two. So I'll solve from these two, and from here we know it is 2n and it is 3n. I'm going to multiply this by 3. So we'll get 2 times 3 and that is 2 times lambda is equal to 3 plus 3 lambda. So it become 4 lambda minus 3 lambda, that is lambda is equal to 3. So once we got lambda is equal to 3, I'll get n from here, that is 3 times n is equal to 2 into 3, that is 6, and hence n is equal to 2. So we got n and lambda, so we can put any value in any of these equations to get the position vector of p. So I'll put n because it's easier. So OP vector, the position vector of p is 2 times 2i cap plus 2j cap plus 3k cap, which is 4i cap plus 4j cap plus 6k cap. So that is the position vector. Now let's do the last part of this question. So the C part, calculate angle OPM, giving your answer in degrees. So I'll draw the figure again. So we need to find the angle OPM, means we need to find this angle. So for this angle we are going to use the dot product, and for that dot product we require these two vectors, that is PO vector, we require PO vector and PM vector. So we'll find these two vector first. PO vector is negative of OP vector, and OP vector just now we got, it was 4i 4j 6k, so it is minus 4i cap minus 4j cap minus 6k cap, and PM vector is OM vector minus OP vector, and OM vector is just half of AB vector, OA vector, that is going to be 3i cap plus j cap minus OP vector. Minus OP vector is this 4i cap minus 4j cap minus 6k cap. So these are the vectors we know we require, PM and OPO, and we can simplify this. It is going to be minus I cap minus 3j cap and minus 6k cap. Now we have this, so we are going to find the magnitude of this vector, because in order to use the dot product we require the magnitude as well. So first of all, dot product PO dot PM vector, it is going to be minus 4 into minus 1 4, minus 4 into minus 3 is 12, so plus 12, and 6 into 6 36, so it is plus 36. It is 36 plus 4 40 plus 10 50 50 and 52. And magnitude of PO vector, it is going to be square root of 4 square plus 4 square plus 6 square, that is 16 plus 16 plus 36, 16 plus 16 plus 36, it is going to be 65351314568. And magnitude of PM vector, it is going to be square root of 1, that is 1 plus 9 plus 6 square, that is 36, so 9 1 10 plus 36 plus 10 46. So it is going to be PM vector. Now the cos of, we'll use the formula cos of angle OPM, it is dot product of PO with PM and then divide by the magnitude of the respective angles, respective vectors, dot magnitude of this and magnitude of this. So we have all the values, it is 52 over root 68 into root 46, and hence angle OPM is equal to cos inverse of 52 over 2 times root 782. We will do by calculator, and this answer is going to be, we need to get the answer in the degree, so be careful, your mode of the calculator should be degree, and the answer is cosine inverse of 52 over 2 times root 782. The answer is coming 21.60 and so on, but we need to give the answer in degree, and we know that angle will always give the answer till 1 decimal place. So the answer is 21.6 degree. So that's the last part of this question and end of the paper. Thank you for watching. Thank you so much. So this is the vector equation of this.